Hello guys, welcome you all for this end-to-end session on AIML where you guys gonna learn everything in order to become a successful data scientist. Hope you guys are enjoying because we have done nearly 50 plus sessions. So you guys now have an understanding of what is the theoretical understanding of what is AIML, and then the background of what is data, where to collect the data, how to collect the data, and we have stepped into a new thing called as machine learning. So hope you guys are understanding everything. So yeah, we are very excited. We are learning every day, guys. Okay, so hope you guys are also doing the same thing. So yeah, today it will be a coding part of decision tree. So before going for this session, guys, again a humble request from our side, just make sure that you guys watch all the previous session videos so that you can have a better understanding of what we are talking. Okay, so today we're going to see, as I mentioned before, we're going to see the coding part of decision tree. So like for this coding part, at least you guys need to watch the previous two sessions where we have explained the theoretical concept of what is decision tree, and what are the ways of creating a decision tree, what are the black box behind the decision tree, like those things we have explained. Okay, guys, please make sure that you have watched previous two sessions so that you can have an idea of theoretical knowledge of this decision tree together with the illusion, or I will say it's a black box of decision tree. Okay, hope you guys have watched that so you can have a understanding of this coding part. Okay, so before going for this coding part, I'm just gonna ask a question: what is decision tree? Okay, so let me know, guys. Guess, just put in the comment section what is decision tree. Okay, I hope like now you most of you guys know what is decision tree. Whenever decision tree comes to your mind, what is coming to your mind? Whenever the question is decision tree, what comes to your mind? Just ping in the comments. Okay, let's see how many of them doing a great job. Okay, like they are watching a video with full focus. Okay, yeah. So what is decision tree? It is like a tree structure where we will be having root node and followed by some branch nodes, and then we will be having something called as a sub branches, and then we will be having the leaf, and we will be finalizing everything. Okay, so guys, so without wasting any time, just dump into today's session, which is a coding part of decision tree. Okay, guys, I hope like you guys have a understanding of that is theoretical and black box understanding of decision tree. If you guys doesn't have, please make sure that you watch the previous two sessions where we will be explaining the theory and the black box of this decision tree. Okay, so without wasting any time, let us do the coding part of decision tree. Okay, so decision tree, guys, before that, this environment is a collab environment. If you guys need to have a knowledge of it, just watch our Python session where we have introduced you this collab environment, how to create it, how to upload the data, how to work on it, everything we have just uh, done there. Okay, end to end giving of knowledge about this collab. Okay, now let us start the coding part of decision tree. Okay, first of all, I'm going to import the necessary libraries. Okay, this is a major thing that we need to do for any machine learning algorithm. Pandas is used to perform some data frame related operations. Dataset, I'm going to use the iris dataset. This is a flower dataset based on the length of leaves and petals. I will say petals and sepals. It's going to predict what is the specimen of the flower, like whether it is a setosa, virginica, and vesicle. It is like a flower name based on four different features like setosa, like sepal and sepal width and petal width. It's gonna classify whether the plant belongs to setosa, virginica, or vesicle. They are the name of the plant. Then we are having train test split, which we're gonna use to split the data for training and testing, which is from the SQL and model selection. And we are just using this standard scaler, which is used to perform some scaling kind of operations. Then we are having decision tree classifier, guys. Guys, this is the only thing that we're gonna use, which is differ from the before syntaxes. Okay, because we're gonna follow all the steps here. Then accuracy score is a matrix which is used to find the accuracy of the classification model. Then we are having NumPy. So NumPy is used to perform all kind of mathematical operation. Okay. Now I'm going to load the data set. It's simple, right? We have already have this load iris. So load iris, I'm going to pass it to the variable called as iris. So I'm going to create a frame, data frame. So iris data and then iris feature names. So and then I'm just passing to the data variable, and I'm creating a new column called as target. I'm just passing the target value. So these are the things that we are having. So we are having sepal length, sepal width, petal width. Based on these lengths, what is the length and width? What is the target value? Whether it is a 0, 1, or 2. Whether it is a setosa, virginica, and vesicle. These are the flowers name. Okay. Hope you guys have understood this. Okay. So till this point, everything clear. So then we gonna summarize our data. So I'm gonna print the head of it. So first 5 records will be there. So if you guys need a tile of it, you need to go for just last five records. You need to go for tile, data dot tile. So you guys see here first 5 records. We are having sepal and sepal with petal and petal with, and then what is the target? Everything belongs to 0. That is setosa. Okay. So I'm just printing the first 5 rows. So since I'm just printing the first 5 rows, it is able to get only the first 5 records where we will be having the target values of setosa. Okay. Then I'm going to use the describe function, which will give some statistical inference amount in, like how many counts of it. Like you guys can see 150 counts, 150 records are there, and mean of sepal length is 5, and then sepal width is nearly is like 3, and here we are having, and then petal length is also 3, petal width is nearly 1.19, like that. So hope you guys can have an understanding, right? This is what the describe function is doing. Okay, then I'm going to print the value code, that is how many target values are there. So guys, see here, for each and every target we are having 50 samples. That is, for setosa we are having 50 samples, versinica we are having 50 samples, and then vesicolor we are having 50 samples. Hope you guys have an understanding. Okay, next, moving on, we are having pre-processing. So we're going to check whether the dataset contain any null values or not. How we can do that means, we need a dataset name, that is data isNull.sum. It's a function which is used to return how many null values are there in the columns which we have loaded as a dataset. Okay, so there is no null values for sepal length, sepal width, petal length, petal width, nothing there. No, all thing on 0, and then the dataset is also in the integer type. Okay, guys, we have just done a very simple thing. We have just loaded the necessary packages. We have just imported our dataset, and we have done some kind of summarization, and now we have pre-processed our dataset. Hope you guys have understand these things. Let us move further. I'm going to segregate my dataset into input and output. Okay, you guys can see, right? X is the input, that is features. From this it is clear, right? Sepal and sepal with petal and petal with, they're going to be input, and my target value is going to be our output. That's the same thing I'm just giving. So yeah, so we're going to have something called as the segregation. Okay, sepal and sepal with petal and petal with, that is except target. Okay, data dot drop of target, that is it gonna remove the target value because it is a prediction, right? I'm gonna remove that, and I'm gonna have everything as a x, that is input, and y is only target value. Okay, x will have 4 values, you guys can see here, right? Sepal and sepal with petal and petal, whereas y is having only target values, that is 0, 1 or 2. Okay, that's it. Okay, now moving on, you guys can see the shape. Okay, 150 comma 4, 150. So we are having 150 records of 4 features. Here, since it is a y, there is no features. Okay, we're going to add the features in the future of this code. Okay, now we're going to do the scaling. Okay, I'm just importing the standard scaler, and then I'm just fitting our x, that is input. So what's the reason we are doing it? So you guys can see here, right? The values are ranging from 0 to 0 point some values to 6 value, 6 the count. So there will be some uncertainty. So in order to make that to equal scales, we are using the standard scaler. Okay. So hope you guys can understand, right? So I'm just passing this input x, and we are getting the standard scalar. So this is what the standard scalar is. Some random value, some random range from -1 to 1 or like that. Okay, based on the data set, it's gonna prepare its own, I will say, its own scaling. Okay. Now, once we are done with our input and output and then scaling, what's the next thing we are having? Yeah. Once we have done with scaling, you guys can see again there is a shape of 150, and there is no change in the feature. Okay. So this is how we can able to verify whether we are doing a thing properly or not. Next, I'm going to split up my data set, that is from train and test, by using a train test splitter from the sklearn module, and I'm just passing the input, that is its scale, and my output is y, and then the test size is 0.2. That is, for testing I'm using only 20%, and then for training I'm using the 80%. Random state is 42. So whenever you guys got run this code for you, you will also gonna get the same output. Okay, so that is what all about getting the dataset into training and testing data. Then we're gonna just specify the shape of it. Okay, you guys can see for training it is nearly like 120, for testing it is like 30. Okay, so this is how I'm just splitting the dataset into train test split. Okay, next I'm gonna load my decision tree classifier model. I'm just specifying to the variable called as model.fit, which is used to fit, that is used to perform the training of it. Okay, so x factor, like x training, which is the data for training. why training is a data for training, but it is a target training data. Okay, like that I'm just giving to it, and then I'm just asking it to like train it. Once it is trained, we're gonna calculate the accuracy by using this predict function, and then I'm just passing the x text. Okay, that means we have trained our model by using fit function. Predict is used to predict the output, like we are having 1 0 2 1 1, so like that. Okay, wherever there is 0, that is called as a setosa. Wherever there is 1, that is virginica, and wherever there is 2, it is vesicle. Okay, hope you guys can understand till this point. Okay, very simple. We have loaded our model, we have trained our model, and then we are going for a prediction. Okay, that's it. Very simple. Okay, now I'm gonna pass accuracy. Okay, I'm gonna set what is the metrics of it. You guys can see I'm just passing the accuracy and this X test, sorry, Y test, which is the data which is present in the data set itself. This Y predict is a value which is predicted by our model. Now one, okay. When I compare that, the overall accuracy is 100%. So now you guys tell me what happens. I'm getting for my model it's 100%. That means what? Okay, I'm gonna explain. Okay, so when the percentage is 100, then your model get like not generalized, it has memorized everything, because like it knows that it is showing the not a wrong accuracy but accuracy which will create a overfitting. So that's the reason you need to just remove the complexity of this model. Okay, but whenever you go for decision tree, it will be the greater problem for random forest also. Okay, you need to somehow tweak the parameters so that you can work on removing the unnecessary things within the class of the decision tree. Okay, now iris dot target names, we are having setosa, vesicular, and virginica. Now I'm just creating my own data set. Okay, we are having 5.1, 3.5, 1.4, and then 2.0.2. So these are some important like input that is created, and when I'm passing it to the standard scaler, it's just able to convert the screen. Like the thing is how the sample is converted in the form of a transform. Okay, once it is done, once it is transformed, okay, like -1 to 1, I'm just passing to the model using predict function. It is predicting the result. You guys can see the predicted class for the sample is, this is what the predicted class that we are having, that is 0. Okay, so the predicted class for the sample is so iris dot target names, then like predicted classes. Okay, like if you are having the like this, it will show the practice class for the sample is, I'm giving 0. That is what it means. uh, it is setosa. Okay, the predicted class for the sample is, so here they are giving voluntarily some information. Okay, so we are having setosa. Okay, 0, when I pass this 0 onto something called as target names and then iris, it will create this kind of output. Okay, so the output is 0, that is setosa. That's it. Okay, so guys, I have done an entire overview of this decision tree model. Okay, let us just break down the steps that we have discussed so far. Guys, please make sure that you have put in the comment what are the steps that we need to do in order to just build and make the decision tree successful. First of all, we need to import the necessary libraries, we need to load our dataset, and then we need to just summarize our dataset. Then we need to go for something like what are the things that we are having related to the dataset. Then we need to apply the decision tree, and then we need to identify whether it is working properly, like whether decision tree is working properly for our data. So then we need to go for a single sample prediction. Finally, if visualization is possible, you can go for it. Okay, so hope everything is understandable. So I have just explained the entire decision tree flow. Let's see what are the extra things that sir is having. Yes sir, over to you.
Yes. So, first of all, what we'll do is, guys, we'll import the necessary libraries, okay? And pandas will sklearn for data set, okay? And we'll iris, we have a data set which is load iris, okay? So we'll upload that and once import that, sorry, and then sklearn model will select the train test split and pre-processing standard scaler will import all the necessary libraries, guys, and scikit-learn.tree, that is for decision trees. We have to import decision tree classifier, and then we have to sklearn.matrix, which is import accuracy score, because we have to check that, and then we have to import numpy as np. Okay, so then we load the data, iris data set, and then we'll yeah, so then we want to see the data, which is like the outcome is here. You can see the data into 150 rows into 5 columns. Okay, yeah, so then we have a summary of the data set. Okay, so for that we'll print data.head, and like we always do, and print data.describe and print data.target, and we'll have the length, width, all those outcomes there for the data. So then we go for step 4, which is pre-processing the data set, and we do pre-processing. We'll check the null values, and then we will get the output according to that. So we'll print data dot is null bracket dot sum bracket, so we get the output of null values. Then we segregate the data into input and output. For that, y equal to data dot drop target axis equal to 1, which is the features. Y equal to data target, which is the target variable. Okay, so we'll get sepal length, sepal width, petal length, petal width. So this is how it will look like, because we have to define x, like x equal to data dot drop target axis 1. Okay, y variable, which is target variable. Okay, so you will get this output. Yes. So for any data you will have, according to data you will get the output. Okay, so again 150 rows into 4 columns, you will have the data of sepal length, petal length, yeah, sepal length, sepal width, petal length, and petal width. Okay, so then we go, yeah, can we go down? Yeah. So target already defined, 150 into 1 column, data type integer 64. So this is the target value output, and then we'll see the shape x and y shape, which is 154 150. Okay, so this is the output, and then we are performing feature scaling. Okay, so you guys know what is feature scaling for. Okay, so feature scaling, then we do it on, we'll scaler into standard scaler, which is the library. X scaled equal to scale dot fit. Okay, transform x, so transformation will happen. Okay, transformation, it is for performance, guys. Feature scaling is always to perform, model should perform well. Okay, so this is the output for x scaled. Okay, let's move to the yeah, can we go down? Yeah, then we have x scale dot shape, so 50 into 4. Then we do split data into train and test, which is very important. And then for that we'll do x text, x train, x test, y train, y text equal to, we'll do this splitting into training and testing. That is the only logic here, but you need to understand the function, so that each function has its own value. You have to define each and every function, and that is the main thing. Okay, then you have the output, which is 124 34 120 30. So that is the output for the x train, x test, y train, y test. Okay, so that is the output for this. Then we load the model for decision tree, because we are using model equal to decision tree classifier. Okay, so that is the model, and then we do the training the model. We'll train the model dot fit x train, y train, and then we go for prediction. So once model is trained, it will take sometimes time. It depends on how much data you have, guys, because sometimes training will take time, okay? So you have to wait, have patience, okay? So then we are going to predict the results using train model, and then we'll see. And if you don't get the right results, so you have to iterate till you get right results. You can make modification, you go and understand what is the problem, whether in pre-processing, in choosing the model, or bias in the data, outliers, or whatever, or you have not taken data from the right source. You have to check all those things. That's why pre-processing is very crucial. I think that is the main job of a data scientist. Okay, pre-processing. You have to know all these things and choose the right model and get the right data as per the problem statement. Then you get the prediction is here, and then we calculate the accuracy of the train model. Okay, and then that is one. Okay. Yeah, then we have iris dot target name. So we have these different categories of the target. Okay, so we have Setosa, okay, Versica, and we have Virginica. So all these are data types. Okay, we have these data arrays, okay, in our model, and then we are going to predict the outcome of single sample using the target model, and then we'll have predicted class for that is 0, and the predicted class for the sample is Setosa, and then this is how. So the process is, if you see from first step to 12th step, if you've seen whatever we have learned till now, you have to use that, you have to apply that. And for that you need to have deep understanding why you're using some functions, why you're using certain concepts, why you're. Okay, so you have to understand end to end. There is no that, okay, I'll focus on this thing, I'll learn this thing only, I'll not learn. Everything is very important, okay? And then we are predicting class for the sample. Predicted class is 0, the out, and then we have predicted class for the sample. Iris target name predicted class is again 0. So yeah, that's it. Anything else we have to discuss?
No, nothing, sir. So this is what all about the coding that we are having for decision tree, sir. Yeah.
Yeah, so you can just use this code, or you can if you can use this code to make your first project, or you can go and learn, and these are the steps to create a decision tree model. And if you keep it doing, keep like you do all the projects, whatever assignments we are giving, and side by side you keep doing whatever we are teaching you, so you will have hands-on experience, and that will be a lot, that will help you a lot, because you will use all your senses for this project. So you can do this assignment, you can see this these steps, you can use the data set. So this data set is available, Raja, which we're
Yeah,
using.
it is a inbuilt. It is an inbuilt
Inbuilt.
data
So
set.
you guys can
Yeah.
use this inbuilt data set and start making your first project on machine learning using decision trees, guys. So you can go and watch all video on, you can go step by step and do all these steps. It would be your first project after, but you have to learn all the sessions 5 to 10 times, guys, because you have to clear all the concepts theoretically and conceptually. You have to do meta level learning, and then you will be able to apply this knowledge deeply, and then you will keep learning and keep learning with consistency, persistency, with patience, and apply the knowledge. Absorb the information, digest the information, and apply, and do all the assignments. Do this project also. Step by step, go in. Uh, uh, First, imitate. See the intelligence. I'll tell you guys. What is the intelligence? You imitate, you mimic the intelligence first, and then you will become intelligent, right? So start using these libraries, these functions, understand the concepts, build your own small projects, and that will build your you will build your capabilities and skills. Okay. Keep learning deeply and watch all the sessions and subscribe to our channels. Also, press the bell icon and write in the comment section if you need any help, and what is your objective function for long term of your career. Keep learning deeply. Thanks.
Yeah, guys, as sir is mentioning, please make sure that you guys have a proper understanding of everything. So if you guys stuck anywhere, just ping in the comment section. We will take up and we will solve your doubts. Okay. So guys, today we have completed the entire coding part of decision tree. Okay. So hope you guys have an understanding of theory plus coding. So this decision tree is completed. Okay. We're gonna see another algorithm in the next session. So until next session, guys, bye, take care, and we will all meet in the next session. Bye, guys.